Sorry about that. Yeah. Oh, welcome back, guys. Right. So what I'm doing right here is I'm just drawing a little grid showing the 2 points. All right. So let us say this is 2 and -5, and this one up here is +1 and 4. All right. Now the shortest distance between 2 points is a straight line. That's how you go. Yeah, man. Yeah, man. The shortest distance between 2 places, you know. I mean, for example, you guys use a lot, you know, a lot of shortcuts. For example, I mean, if you're in your classroom, right, where your classroom, and you know, and you want to go to the staff room, all right, you guys are not gonna walk all the way along the corridor, down by the electrical block, by the reading room, and then go past the grade 7, then go to the staff room. You're not gonna do that. What you gonna do? Walk straight in a line with you, right? Well, except when rain is falling. All right. So in other words, this question wants us to find the length of this line. All right. And anybody remember the formula? Finding the length of a line. That's the formula. All right. So what you're gonna do? You're gonna choose any one of them to be x1. Let's call this x1 and y1. Let's call this 2 x2. And let's call this 5 y2. So all you need to do is plug in those values in the formula. All right, so notice this is x2 minus x1, y2 minus y1, and in between we have a plus, and we square everything. No, you don't have to write, it doesn't matter if you want to write y2 minus y1 first, doesn't matter. All right, so you're gonna have 2, this is x2, subtract x1, which is 1, square, plus y2 is -5, subtract y1, which is 4. All right, so go ahead for me and tell me what the answer is. Any answers?
C, sir.
Okay. Daniela got C.
It's Yolanda got C, but I got C too.
Oh, sorry.
I got C too.
Okay. Yeah, C is the answer. So, I mean, that's going to be 1 square.
Plus 9.
Well, that's negative 9 actually.
It's because that's okay.
All right. Well, I mean, you're gonna get 9. I mean, you're gonna get positive 81. You know, give or take. But it's actually negative 9. So, so negative 9 square is 81, and 81 plus 1 is 82. So the answer there is root 82. Any questions? All right, moving on. I'm going to erase this drawing, this nose here. About to finish? All right. All right, before we get to this question here, let us look at this question first. All right. All right, so this is coordinate geometry. And all right, so let's say we have another grid, right? And let us say we have a straight line, for argument's sake. Now, to get this straight line, right, we have to plot some points, don't you? Give me a second, guys. All right, sorry about that. So we have a straight line, right? And to get the straight line, we have to use some points, and we plot those points, and we draw a straight line. All right? Can anybody tell me what those points are called? It's a phrase. It's a set of something.
Scale.
Say that again?
Scale.
No. It's not scale. It's called a set of ordered pairs. So we use a set of ordered pairs to plot the straight line. And we usually get those ordered pairs from the equation. Alright? Now, this question is asking us, right? Oh, by the way, all straight line has the form of y equals mx plus c. You guys remember that?
Repeat that, sir. All straight line have to do what?
All straight line has the formula y equals mx plus c.
Oh, yes.
Come on. I remember doing this topic here. And we said that x and y are variables. And we said that m represents what? Anybody remembers?
Gradient.
Right, the gradient. And the gradient can either be positive or negative.
Negative.
Right. And I don't know if you guys remember that I said that if the line is falling to the right,
Positive.
it's positive,
It's a
right?
positive gradient.
Right. And falling the other way, it's going to be negative. All right. Can anybody tell me what C represents?
Gradient. The intercept or something like that?
Right. Very good. It's actually, well, you have to be specific. It's actually called the y-intercept. Because you know that the straight line can intercept on the x-axis. All right. All right. So, if you guys go on my YouTube channel, you know, I just posted a video for the grade levels on relations, functions, and graphs. So you can look at it. goes through all of these topics here, like gradient and all of that. All right, so as you can see, y equals mx plus c. All right, can someone tell me what the gradient for this straight line is?
2x.
Right, it will be 2. Well, you're not going to say the x, so it's actually 2. All right, and what can you say about the straight line? Is it falling to the right or falling to the left?
Left.
Sure?
I say left.
Come on.
Just the 1 -3, I'm gonna say that.
No man, remember saying no. The
Oh, we're dealing
gradient.
with the 2. We're not dealing with the
Right. So you look at the sign for the 2, for the gradient, and this gradient here is positive. So the line is falling to the right, and it will cut the y-axis at -3. All right. So, are you guys following me? I mean, are you guys getting what I'm saying?
Yes, sir.
All right. I hope that everybody is saying yes, sir, too. Because I remember doing this in class. I don't remember who was there. All right. And sometimes when I have class, people gone on trip all over the place. I don't know. Anyways, I remember doing this though. And you should have, this is actually a great, this is actually a sexy topic. So it shouldn't be much of a big. All right, now this question is saying, which of these following points, they're talking about the ordered pairs. So these are some ordered pairs, right? But let us be frank. I could have a point like this, don't you? No, this point here, is it on a straight line? No, it's not on it. But how do we prove that this point is not on a straight line mathematically? Physically, we can see that it's outside. All right. So let us assume that A is the answer. All right. So I'm gonna try to prove that A is on the line or not on the line. How do we do this?
You find the coordinate or no? Okay.
No, we don't find the coordinate. But I'm not sure which coordinate it's talking about. But no. Well, we're trying to find some coordinates that are actually on the line, because all of these are coordinates, you know. But we're not sure. We want to know which one is actually on it. All right. So I'm using A as my first choice. All right. So this is what you do, right? Now, the y value would have been 3, right? And x value would have been 2. Now, 2 times 2 is what? All right. Is 4. And 4 subtract 3 is what?
-1. No, just 1.
It's just 1. All right. Now, is this statement a true statement? No, that's not true. 3 can equal 1. 3 have to be equal to 3. So the left hand side is not equal to the right hand side. So hence, it cannot be the answer. All right. So you guys go ahead and tell me which point is on it. I mean, how you know which point? When, for example, if when I work out this, I get 3 on the right hand side, then the answer would have been correct. All right. So go ahead for me. Try B, C, and D. All right.
I'm HD.
All right. Tashan got D. All right. Anybody else?
D.
All right.
Turn the rice down.
All right. Tashan at church today?
No, sir. My sister, they listen to Shibada live.
Oh, okay. All right, so D. So D turns out to be the answer, right?
Yes, sir.
Yeah, man. Everybody agree? Shanicia, Yolanda?
Yes, sir.
All right. All right. All right, so moving on. All right, so let's look at this question here, right? And this question takes a lot of thought. All right, so we have give me a second here. Well, this question is very similar to one we did a while ago. All right, but I'm gonna draw a picture of what's going on. So let us say PQ. We have a line like that's PQ. All right, let's imagine that is PQ. All right, now perpendicular. What does perpendicular mean?
Right angle, 90 degrees.
Right angle, 90 degrees. Yeah. What's a bisector?
Something that cuts a line in half. Two.
In two, yeah. So a perpendicular bisector is a straight line. Oops, that should be in the middle, but it's not. But let me try. All right. So a perpendicular bisector is just a straight line that cuts the initial line segment into half, and it cuts it at 90 degrees. All right. All right. Now, so what we need to do is, hope you guys writing down this. Number one, we need to find the midpoint of the line segment PQ. The midpoint formula is capital M. Anybody remember what the midpoint formula is? Either from 6th form or from grade 11? It's simply x1 plus x2 divided by 2. And you can see the reason why we divide it by 2, right? It means the midpoint. And then we have y1 plus y2 divided by 2. Alright? So can somebody work out the midpoint for me? So let's call this x1. Let's call this x1. y1. 7 is x2, I don't have no space, and negative 1 is y2. Somebody tell me what the answer is. Well, I mean, this answer doesn't give the answer to the question. We're just starting a process. We're just working on the midpoint.
Two.
You got C?
I said 2.
You got two. No, it's either. No, what's the first number? Oh, 2.
Yes, sir.
You sure?
No, sir.
I can't 2, man. Because 1 plus 7, you know, 1 plus 7 are what? 1 plus 7 are 8, you know. 8 divided by 2 are 4. So it's either 8 divided by 2 is 4. So the first number there should be 4.
Oh, because I know what I did.
Right, so what's the other number?
The other number is 2.
Right, I didn't realize I could actually write over here. All along I was just like confined to this space. But look, I can actually write on it. Alright.
You see? Well,
Right. So no man, remember the midpoint is not an answer to this, We haven't reached the answers yet.
oh yeah.
Right, so the other one is gonna be 5 plus minus 1 divided by 2. Now plus minus together give you a minus. 5 subtract 4. Sorry, 5 subtract 1 is 4. 4 divided by 2 is 2. So the midpoint is what? 4, 2. Alright, so any questions so far? Alright, so what we did a while ago, you see, was to work out the midpoint. Now, would you agree with me that the midpoint touches the 2 line? The midpoint touches PQ.
Yes, sir.
And the midpoint touches the other line. It's like a scissors, the middle part of a scissors. That little thing that holds the scissors together. That knob, it touches both blades, don't you? Alright. Now, when 2 lines are perpendicular, right? Something special happens when you multiply their gradients. So PQ of a gradient and the perpendicular bisector of a gradient, but they meet at right angles. Now when 2 lines meet at right angles and you multiply the gradient, what happens? Anybody remember?
Equal 1.
It's equal to, you're almost there, -1. Alright, now the gradient of PQ. We need to find the gradient of PQ, don't you? Alright, this question dangerous, Trust me. This question dangerous. It is very long. So, anybody want the formula for a gradient? For line segment? It's y2.
Yeah, y2 minus y1.
y1 over x2 minus x1. Alright. So let me encourage you to look at my YouTube channel. I just posted a video on relations function and all of this stuff for you. So y2 is -1 and y1 is 5. That's 7 subtract 1. Alright, somebody tell me what the answer is in its simplest form. And we're working on the gradient. Alright, so the numerator would have been what? -6. And that would have been 6, don't you? And that's going to give you -1, don't you? Alright? So the gradient of PQ is -1. Alright? But what we're going to do eventually is to actually find the equation of the line, the perpendicular bisector. That's what we need to do. So we need to find the equation of this line here. All right. Now earlier on, I said that when two lines are perpendicular and you multiply the gradients, you get -1. So the gradient for PQ is -1, right? Now, do we know the gradient for this perpendicular bisector? we know it? I mean, can we find it?
Yes.
Okay. How do we do that?
So, if you just find what you can multiply -1 by to get -1.
Right. I think you're right. You remember? Yeah. Basically, is it because we don't have any points on these two lines here? Because if we had 2 points, then we could use the formula to find a gradient. So what we do, find the gradient for PQ because they give us the points for PQ, and then we use the formula. We say, okay, M1 times M2 give you -1, but -1, which is M1, multiplied by a number will give you -1, and that number turns out to be what? What's that number?
1.
That's to be 1, yeah. Because -1 times 1 will give you -1. All right. So let me what? 10 minutes already. Okay, finding this marker on this computer is very takes about 5 seconds. All right. What if you see? What if? I'm just going off a little bit. What if the gradient for the first one was a -1/2? Suppose the gradient for PQ was -1/2. What number would go there? So when you multiply it, you get -1.
2.
Very good. Because 2 times 1/2 will give you 1, and negative and a positive will give you another 2. All right. So the gradient for the second line is 1. All right. So the gradient for the first one is -1, and the gradient for the second line is 1. Now, why do we need the gradient for the second line? And the second line is actually called what? The perpendicular bisector. Look at the question. Which of the following points is on the perpendicular bisector? In other words, is these points here? What they're saying, one of them is actually on it. But we need to find out which one. All right? But you guys remember a while ago when we did the question, they had an equation, not true? So we need to find that equation. All right? And to find an equation, we need a point and we need a gradient. And do we know the gradient for the perpendicular bisector? Yes, it is 1. Do we know a point on the perpendicular bisector? Yes, it is the what? The midpoint. All right? So we have a point and we have a gradient. All right, now I'm trying to remember how I showed you find the equation. Can somebody remind me how I showed you? Did I find C? Did anybody remember of doing that?
What
I
to do
think
what?
to find C. Did we do that?
Wait.
I showed it 2 ways, don't you? All right, while I'm waiting, time is going, but I'm trying to remember how I taught you to do this, right? So I'm just going off of memory. So it's the formula is y. What we do? We choose a point, right? Let's choose P. And we say y subtract the y value, which is 5, equal the gradient, which is 1 from up here, multiplied by x, take away the x value, which is 1. Anybody remember me doing this? or did I put the x minus 1 as a denominator and then put everything equal the gradient?
I see something in the book will talk about equation of a perpendicular bisector. That's what you're talking about.
Well, just equation of a straight line in general.
Well,
I'm trying to remember how did I show you to find the equation, because there are two ways. I think I remember finding I used when I was teaching at Greenpoint grade 11, I used the C method, but I decided to use another method with you guys. So
I'm sorry, I did put the x minus 1 down the bottom.
Oh, cool. Right. But eventually it's a good person. You realize that? Yolanda? It's the same thing, you know?
Yes, sir, I realize, but I did just go back in my book and see example.
Very good. All right. So in the notebook, right? I have y, subtract the y value, divided by x, take out the x value, but I have that as a divide.
Yes, sir.
And then my next step would have been to cross multiply, and then you get that this line. All right? Right. So I'm assuming that we're at the second line in this. All right. So, oh man. All right. So we're gonna what am I trying to do again? I'm trying to find the equation of the perpendicular bisector. And when I have the equation of the perpendicular bisector, I'm going to determine which of these points actually lie on it. All right. So, come on, very wicked question. I don't like it at all as a multiple choice. So we're going to write about that. No, one times anything in the bracket will give back the same thing. All right, so we're going to make y the subject. So we have y equal x subtract 1 plus 5. So end up with y equal x. Oh boy, I'm going to space right now. X plus 4. All right, so this is space. Scary stuff. All right, so this represents equation of the what? The perpendicular bisector. So something we have to do? Let us go back what we did. Let me just talk about what we did. First thing we did was to find the midpoint. Then we had to find
some gradient.
The gradient of PQ. We found the gradient of PQ. Then we use the rule that says M1, M2 equals -1 when the lines are perpendicular to find the other gradient. All right. And then when we found the other gradient, we find equation of that line. So we're at this juncture here. All right. Then now we're going to have to pick these numbers, right? Can you pick which numbers would work? Meaning that what is on the left will be what's on the right. That's what they're asking. Anybody? All right, let me see if I can go into space again. Let's try A. I think A is the answer. Let's use the formula. Y equal x plus 4. So remember now, y is 4. X is what? 2. What's 2? No, it's not 8. No. 2 plus 4 give you what? 6. That's wrong. So it's not 8. Alright? So which one is it?
Sir, I think it's C.
Okay, let's try C.
No, try D. D. I said D.
All right, let's try D. So y is 8. So remember, we're using this formula here, right? This formula here. So that's going to be x. X is 4. 4 plus 4. Well, what do you know? 4 plus 4 is actually what? 8.